Hi guys, it is day 5 in geometry, and what we are doing right now is working on just some angle relationship practice. Excuse me. So this first page, I'm going to rip right through just because there's nothing new on it. So it is reference for you. The fact that vertical angles are simply equal to each other, all right, or congruent. You can say it either way. Adjacent angles, it's just an example where they share the same vertex and they share a common side. Supplementary angles, that's just a particular example of supplementary. They add that together. 60 plus 120 equals 180 degrees. There we go. A linear pair also are supplementary, but specifically they have to be drawn adjacent to one another. So 40 and 140 also adding up to 180 degrees, right? So I'm just going to say 180 and adjacent so that they form a linear pair. Complementary angles. No, it's not them saying nice things about each other, although that would be nice. It's the idea that 30 and 60 add up to 90, or in this case, the 40 and 50 add up to 90. So there's just multiple examples. So keep in mind, it's the equals 180 and the equals 90 degrees here. And then angles of parallel lines. There's, some examples given here where you can see that the only two angle measures popping up are the 70 and 110, but the pairs that you need to know, corresponding angles. I'm going to use that little symbol for angles here. Alternate interior angles. Alternate exterior angles. And then same side interior. And now those are all in the notes before, so you don't really need to take them again, but I'll put one little example next to each one. So corresponding would be like angle 2 and angle 6 right here. Alternate interiors would be like angles 4 and 6. Alternate exterior would be like angle 1 up top there, and then angle 8. And then same side interior would be like angles 4 and 5. All right. You could also mention vertical, but we mentioned vertical at the top. So let's keep moving. All right, on to the next page. We're going to have all sorts of practice with this stuff. So before that, there's two last, and I guess you could say like new concepts, but I doubt they're even new for you. So what they are, whoops, just trying to align myself there, is angles at a point and then perpendicular bisector. So angles at a point, what we mean by that, if you have 3 angles that go all the way around one particular center point, so that 140 degree angle, 100 degrees, and 120, what you notice when you trace them all out is you essentially create a little circle right there. And we know that a circle has 360 degrees. So those angles are going to add to 360 degrees. The one other detail here is a perpendicular bisector. And so if I have segment AB, this segment here is coming through, cutting it into 2 equal parts. That's the bisector piece of it. And then perpendicular means it's forming 90-degree angles. That's this piece of it. All right. So when you have a perpendicular bisector, all right, it's a segment that divides, I'm going to say AB so that you can see it in the diagram, into 2 congruent segments and forms 90-degree angles. So you've got the 90 degrees, there's the perpendicular, chopped into 2 equal parts, that's the bisector piece. Okay. We are going to fly through some of these first ones. You're going to want to have your calculator next to you. I will skip some, and then maybe we'll talk about them in class because there's a lot of examples in the notes today. So under the first practice, it's asking you to find just the measure of angle DCE. So locate that angle first. So for tracing, DCE, that's this guy right here. If you look very closely, that little marking there, that is a little right angle notation. So to be able to solve for it, you can set up a full equation, or you can simply think about the fact that together, these are all going to be 180. Because that's a right angle, that little piece is 90. And you can absolutely just go to 180 and then subtract the 72 and the 90. If it's easier for you to put an X here and then set up an equation, you can always approach it that way. So I'll let you kind of choose how you handle that. Otherwise, I'm going to go 180 minus 72 minus 90, and that leaves me with 18 right there. So my tiny little angle would be 18 degrees. Same type of concept when I slide it on over here, when it's asking you to find the measure of angle HKI. So HKI, this is an example of you have three angles, but it could be more than three, that all together wrap completely around that point. So that's what I mean by angles at a point. So together they should be 360. So we can simply take 360 and then subtract the 133, subtract the 147. Now, could you add the 133 and the 147 together first and then subtract? Of course you can. So I could do this and then go 360 minus 280, and that would be perfectly fine. Either way, I should be left with 80 degrees right there. All right. Sliding on down to the bottom. Now we get into some where they already have X's and so on in them. Let me see if I can back this up just a little bit. There we go. So for number 3, find the value of X. What you want to take advantage of here is you have a ton of angles that wrap itself around a point. So altogether, we're looking at 360, or you can isolate and say we have a straight line, and any straight line or straight angle has to be 180. You also have vertical angles here. So I'm going to mark some things. This angle here, that's 8x minus 1, its vertical angle across from it would also have to be 8x minus 1. And then if I want, I could also label this down here, 5x. This would be 5x. And then if that's a right angle, its vertical angle would also be a right angle. So I can use the fact that all those angles add up to 360, or I'm going to kind of shortcut and I'm going to use this straight line here and focus on the fact that those three, because they form a straight line, have to add to 180. So 5x, 8x minus 1, and then that right angle, so I know that's a 90 right there. So I'm going to set up my equation below. So 5x plus 8x minus 1 plus 90 equals 180 degrees. Add it together and clean some things up. We get 13x plus 89. Subtract that on over. We're going to get 13x equals 91. Ooh, I'm just off the page. Divide by 13. And I can grab my calculator here. If I do 91 divided by 13, I get x equals 7. And then if I look at the directions, it just asks you for x for this one. So that's it. Right? If it asks you to find the angles themselves, then plug back in. All right, example 4. This kind of hits all the different angles we talked about. It says in the diagram, we've got parallel lines. So CD is parallel to EF. That's pretty important to know there. Angle BHF, so trace that out. BHF, that's this angle down here, is 112 degrees. Find all the missing angles. As soon as you know one and those lines are parallel, you know them all. So you can immediately label the vertical angle, and then you could label the corresponding angle, and then its vertical angle. Mm-hmm. And then to get the other pair, the fact that these are all supplementary, we can go 180 minus 112 and lands you at 68. So all those remaining angles here should be 68 degrees. So 68 here, here, and here. Oops, I'm a little off the page there. There we go. Oh, wrong direction. Okay, sorry. When I move the paper, it moves the opposite direction as what I see on the screen. Sounds weird, but that's why if you find me kind of moving the paper back and forth, that's what's going on. All right, let's keep on moving. The next one for number 5, now we get to set up a little equation here. So given the following parallel lines cut by a transversal, find the measure of angle 1. So ultimately in the end, we want to find that angle. All right, you got to work with what you're being given. So in this case, the two angles that I actually have labeled with degrees are the angle across from angle 1, this guy right here, and then this one down here, 45. Those two angles don't have a particular name. They're not a certain pair, right? But what we can do is if this is 45, we can label the angle across from it as 45 degrees. And these two angles are a particular pair. Those are same side interior angles, which means they're supplementary. They add up to 180 degrees. Right? And so because they add to 180, I can create an equation showing that. So I can take that 5x plus 35, add to it 45, and together they have to be 180. So 35 and 45 should give me 80 right here. And then when you subtract it from both sides, you're left with 100. Divide the 5 out, x comes out to be 20. As always, reread the question. If I just needed x, I'm done, but they want to find the measure of angle 1, which we noted is the same as this guy right here. So let's plug back into that. So if we look, the measure of angle 1, we can do 5 times 20 plus 35, and that should bring us up to 135. Now, to be honest with you, could we have answered that without ever solving for x? Yep. So if this was a quiz, the quiz question would probably say, hey, solve for x, not just the angle measure, because then we wouldn't have even had to do that work. So that's why I wanted to do that one to be able to chat about it. All right. For the ones here, this is just picking out and labeling angles. So for number 6, it says use the following diagram. It is a little messy. Sorry for all the dots on it. It's just a little bit old. And it's saying use it to answer the questions. So for the first one, when it says name an angle supplementary, I'm going to zoom out a little bit so that hopefully you can see multiple things at the same time. Let me slide this forward just a little bit. Here we go. All right. Name an angle supplementary to angle HZJ. So let's find that. HZJ. That's this guy. All right. For it to be supplementary, supplementary, remember, means adds to 180. It has to form a straight line. So I can either take a straight line and go up and over this way, or maybe I take a straight line and I go down that way. In that case, I can answer it with HZG. So is there more than one answer? Of course. Yep. Name an angle complementary to angle HZJ. So we're back with that same angle. If you look closely, because it is a little bit of a mess, if this angle's 90, so is the one next to it. So that means that these two angles together on the left create 90 degrees right here. So that would be that angle JZA. All right. And then it's asking you, find the following angles, give an explanation. It's really just asking, do you know your angle pairs? So if that angle that we keep talking about, HZJ, is 38, can you tell me what the other angle measures are? So FZG, that one, if you look, is its vertical angle. So that also has to be 38. And we can simply just say, because, vertical angles are, you can say equal, you can say congruent, however you choose to say it. Right? HZG, we already said, is its supplementary angle. So we would go 180 minus 38, which should land us, I believe, at 142. And so that's because there's supplementary angles. And now I'm abbreviating. So feel free to write out the full word. And then the last one, AZJ. So that was that top one that it's complementary with. So 90 minus 38, that should leave us, oh geez, I want to say 52, but I could be wrong. 90 minus 38, oh, it is 52. Sometimes I trust my mental math, not all the time. All right, and that's because they are complementary angles. All right. We skipped an example like number 7 in the last note, so I definitely want to do number 7 together. Right? It says, given that we have parallel lines, can you find the measure of angle GHI? So in the end, I want this angle. But why this one I want to make sure to talk about is if you look at the expression, it's got an x squared in it. And we hadn't done one with an x squared the other day. So these two angles, they are same side interiors because they're on the same side of the transversal in between the parallel lines, which means they add up to 180. So let's set it up. X squared minus 20 plus 10x equals 180 degrees. All right, let's rearrange some things. Bring the 10x up, and then let's move the 180 over. So if we subtract 180, then we've got minus 200. Right? So when you think about this, this is a question, Algebra 1 style, that we need to factor. This is going to be one of those add, multiply, guys. If you need to remember how to find factors of any particular number, as a quick review, into your calculator, you can go into y equals, and you could do 200 divided by x, and then you can go look in the table. And so you can find like 1 times 200. I realize my screen's a little bit blurry here. But then if you work your way down, what you're going to find is 10 and 20 multiply to 200 and have a difference of the 10 that we want here. So let me zoom that back up. So we can have x and x plus 20 minus 10 so that they add up to a positive 10 here. And then you can keep going. So x plus 20 equals 0. So you get negative 20. X minus 10 equals 0. You'd get positive 10. Now, do you immediately reject the negative? Tell yourself no right now, because sometimes it works. Sometimes it works. And this time it's not going to. So I plug in a negative 20 here. I'm going to get negative 200 degrees. So much of that makes no sense. So get rid of that. If I plug in a 10, 10 squared would be 100 minus 20. That would come out to be 80. 10 times 10, that would be 100. That one checks out just fine. So when it asks you to find the measure of GHI, that is that 100 degrees right there. Awesome. All right. As for what's left, let's see. I'm going to skip on over here. I think I want you guys in the post video question to tell me what you got for the value of x in this question right here. So when I say number 8, just this one. So let's consider this like 8a, and that would be like 8b. So don't worry about 8b. Tell me the answer you get for 8a when you finish the video. All right, let's slide on down. We've got a couple other questions. Let's jump on down to number 10. Here's another one with an x squared, but it comes out a little differently because here you've got corresponding angles. So these two, you have to set equal to each other. All right. Let me zoom in a touch there. So we've got 8x squared minus 9 equals 7x squared plus 8. Right. If I subtract the 7x squared over, and at the same step, I'm going to add the 9 to the other side. Right. So I, end up with x squared here. Just making sure I copied everything correctly. I did, yay. All right, and then I have 17. All right, it's not the prettiest thing, but that's okay. So now when I go to take the square root, since it's just x squared all by itself, I'm actually going to be stuck with that radical 17. Something about that seems kind of weird to me. Subtract, they gave me an x squared. No, unless there's a typo, but if there's a typo, that's okay. That's not the end of the world. So now it's asking us to find the measure of angle DEF. So let's give it a go. So measure of angle DEF, that is this guy. So we're going to plug right back in. So let me slide over. So we're going to plug in 7 times radical 17 squared plus 8. All right, well, when you square a square root, those are inverses. They just cancel each other out. So you end up with 7 times 17 and then plus 8. So let's grab our calculator here. So if we do 7 times 17, and then add 8 to it, we end up with 127 degrees. All right, I shouldn't have doubted. Looked a little strange for a second, but worked out just fine. All right, we are down, I think, to the last examples that we're going to cover. Number 9, if we have time, we'll cover tomorrow in class. Right? Last page. I like these ones just because if you notice, all of them have X's and Y's mixed together. So now we're really going back to some Algebra 1 review here. And that's what was called a system of equations. I think there's one where maybe you can avoid the system, but most of them, you're going to have to create a little something here, right? So if we look, let's see, you've got this angle, 4x minus 5. So that's what's being labeled, by the way, are angles. So those should have like degrees on them in case it's not clear, all right? That angle is 3y plus 1, and then this angle is 3x plus 11. So if we actually look, we've got those arrows, meaning those lines are parallel. So if we look closely, this is one of the ones that, ooh, that's blurry, that we do not have to create a system. We can actually get around it if we get kind of smart here. And what I mean by that, this top right, that counts as a pair of corresponding angles, which means they're equal. And both of those expressions just have x in them. So let's set up an equation for that. That means that 4x minus 5 is equal to 3x plus 11. All right, let's shift some stuff around. I'm going to subtract that 3x over. I'm going to add the 5 to the other side. And right there, bam, there's my value of x. All right, so there's x equals 16, and we're done. To now get the value of y, let's use that value of x to help us. So if I want to, I can plug in and solve for this angle. I'll circle it right here. So let's plug in and solve for the one next to it. So 4 times 16 and then minus 5. 4 times 16 is 64, unless my mental math is failing me. All right, and then subtract 5. That's going to be 59 degrees. So if that's 59, and those two angles, my one that I circled in blue and the one I circled in red, form a straight line, it means they have to add up to 180. Right? So that means if I go 180 minus 59, I'm going to get 121 degrees for my red angle. So this right here should be 121. And now let's go ahead and set that expression equal to 121 degrees. So 3y plus 1 equals 121 degrees. Subtract the 1. We get 3y equals 120. Divide by 3, we get y equals 40. Awesome. Done. Now, could we have done it a little bit differently? Yes, we could have. So sometimes you might see one way, I might see another. Right? Neither one's more correct than the other. It's just a matter of, can you find a way that works? So as for these last two, we're going to save them to talk about in a little recap in class. So if for any reason, if that is a little tricky for you, then whether you're in class or at home, the day that we go over this, maybe you need to log into class and watch. All right. Thank you guys. Have a good rest of your day.